Hey everyone, Mr. Newman here, and today we're going to learn about solving equations by taking a square root. Now, these are all quadratic equations, which means there's an x squared term in them, and we're going to slowly build up the complexity of the quadratic equations to where you'll be able to solve some pretty complex looking equations. So let's get started. First of all, when you have the equation x squared equals 25, here are the steps you should do. I'm going to rewrite the equation, and I leave some space between the equals and the 25 because I need to take the square root of both sides. However, anytime you take a square root, you must always put a plus and a minus, just like that. Plus, the way what you call it is plus or minus. The reason we have to do that is because anytime you take a square root, you actually need to identify both solutions. Let me show you what I mean. Well, first of all, the square root of 25 is 5. And we want to write that as plus or minus 5. Now, what that means is we have two different correct answers, two different values that x could be. X could be 5, positive 5, or x could be negative 5. That's what the plus or minus means. You've heard me mention before in class that mathematicians are lazy. Well, this is one of those situations. Instead of writing out x equals 5 or x equals negative 5, we just write x equals plus or minus 5 to represent both solutions. Let me show you why we need to identify both solutions though. If we were to go to check our work, we'd want to plug in the answer back into the original equation. X squared equals 25. So something squared equals 25. Well, let's check 5. 5 squared is indeed 25, so 5 works. Check. However, if we look here at the negative 5 times negative 5 is positive 25, so that also works. So, check. We have two different solutions for this one equation, and that often happens when we have squares. So always put your plus or minus. Let's go ahead and jot that down. Always write plus or minus when taking a square root. All right, let's try the next one. So x equals 5 or x equals negative 5, that is the answer to that first problem. X squared equals 16. Well, to solve this, we're going to take the square root of both sides. So the square root of x squared and the square root of 16, we need to remember to write plus or minus. The square root of x squared is just x because square roots are the opposite of squared, so they undo each other. And the square root of 16 is 4, so we write plus or minus 4. That is our answer. Now notice, you don't have to write out x equals 4 or x equals negative 4. You don't need to write that whole sentence out. You can be lazy like mathematicians and just write the plus or minus. Just recognize that that means you have two different solutions. Go ahead and try the last one on your own. And before you do that, I actually want you to list out the perfect squares. These are a list of numbers you should have memorized. For example, you should know that 100 is 10 squared. So the square root of 100 is 10. The ones that students often don't have memorized are those last few. 169 is this 13 squared. The square root of 196 is 14, and the square root of 225 is 15. Make sure you have that whole list memorized because you'll need some of those square roots in class. All right, try the next one on your own. Have you got it? Well, here is how you want to do it. X squared equals 81. The square root of x squared is equal to the plus or minus the square root of 81. So don't forget your plus or minus. So x equals plus or minus 9. All right, for the next one, we now need to get x squared by itself because the equations are not always going to be set up that simply. Here, in order to get x squared by itself, we're going to add or subtract or multiply or divide. So let's add 7 to both sides in this first equation to get x squared by itself. We get x squared equals 9. Aha, now we can take the square root of both sides. We cannot take the square root when there's other things around because we are taking the square root of the entire side. So if we tried taking the square root on that first step, we would get stuck there. So the square root of both sides, the square, don't forget your plus or minus. X equals plus or minus 3 is the final answer. Go ahead and try this next one on your own. We're trying to get x squared by itself, so add 30 to both sides. Now we have x squared equals 36. Take the square root of both sides, plus or minus, and x equals plus or minus 6 is the answer. On the next pair of problems, we have to do one more step. You can kind of treat this like a two-step problem, only I guess it's really a three-step problem. So see the x squared there? We're trying to get x squared by itself. So let's add 8 to both sides first. Then we get 2x squared equals 8. Now we can divide both sides by 2, and we get x squared equals 4. Now we're at the stage we can take the square root of both sides. So square root of both sides, write down your plus or minus, and x equals plus or minus 2. This is the answer. Try the next one on your own. All right, so add 7 to both sides. 3x squared equals 12. Divide both sides by 3, and you get x squared equals 4. Now that x squared is by itself, this is the stage where we can take the square root of both sides. So square root, don't forget your plus or minus, and x equals plus or minus 2. So I want to show you guys real fast. You can actually check this with the calculator. The trick is you need to get it equal to 0 first. So set the equation equal to 0. I'm going to show you how to do this on this very last one we just did, checking your work with the calculator. It involves graphing it and then finding the points by pressing trace. So first let's get this equal to 0 on one side. This is different than how we just solved it. We're actually going to subtract 5 from both sides. And we have 3x squared minus 12 is now equal to 0. Great, now that it's equal to 0, let's graph that into y equals, the 3x squared minus 12. So I type that into y equals, remember your y equals button is right there, 3x squared minus 12. Then I'm going to press the trace button. You can actually press graph then trace, but you can also just press trace. Once you press that, you'll get a screen like this. Notice that it starts off at x equals 0. Now we just need to type in our two solutions. We have x equals 2 and x equals negative 2. And we want them equal to 0 because that's what we set the equation equal to. So type in 2. When you press 2, you should get a screen that looks like this. And then you press enter and it graphs x equals 2, y equals 0. Because it says y equals 0, that's correct. So x equals 2 is one of our solutions. Check. Likewise, when you type in negative 2, you get another 0. So that's another solution. That is a quick way to check your zeros. Now remember, zeros, solutions, and x-intercepts are all the same thing. So you should notice that those 2 points are the 2 points on the x-intercepts where we see them on the graph. That's how the parabolas are connected to the solutions of the problems we're doing right now. All right. Moving on, sometimes we don't have perfect squares. In a sense, those are sometimes a little bit easier because let me show you. There's one less step you have to do. X squared equals 6. Take the square root. Don't forget your plus or minus. Now, the square root of x squared is x, but because 6 is not a perfect square, we have to leave it under the radical. That's what the square root symbol is called. So our answer is x equals plus or minus the square root of 6. Don't forget that still means we have two solutions, x equals root 6 and x equals negative square root of 6. So you can either write it like that, or you can write it as the one up above there. See how that's one less step? We don't actually have to take the square root of 6 because we can't. Try this next one on your own. All right, did you get it? X squared equals 7. Take the square root of both sides, and x is plus or minus root 7. Now, sometimes though, that's not all we have to do, unfortunately. sometimes we have to simplify the radical. Let me show you in this first situation. If I have x squared equals 50, I write plus or minus root 50. I need to simplify this radical. Now the radical is just another fancy word for all the square roots or cube roots or other kind of roots, but we're just working with square roots in this class. X equals plus or minus root 50 is not the final answer because that can be simplified. It's kind of like if you had a fraction, if you had 4 over 2 or 3 over 6, you wouldn't call that simplified because you wouldn't be done because you can simplify the fraction. Likewise here, we can simplify this radical, so we need to simplify it if we can. The reason we can simplify it is because there's a perfect square inside of 50. Now, you can write 50 like this, 25 times 2. And when you have multiplication, if you have a square root of two things that are multiplied, that's the same as the square root of one times the square root of the other. In other words, you can break apart the square root just as I did right there. But because we wrote it like that, you can see, wait, the square root of 25? The square root of 25 is just 5. So this is the same as writing plus or minus 5 times the square root of 2. That 25 became a 5. So this is our final answer. That is simplified. The key here was that we had a perfect square inside of 50, and that perfect square was 25, and we identified it. So for this right here, I want you to try this next one and try to find the perfect square that's inside of 12. All right, I'll show you how to do this one. X squared equals 12. Take the square root of both sides. Don't forget the plus or minus. X is plus or minus root 12, but that's the same as plus or minus root 4 times root 3, because 4 times 3 is 12. The square root of 4, that's 2, so we can rewrite that as plus or minus 2 root 3, and that is our final answer. One way to check and make sure you simplified something correctly is to check it with the calculator. For example, on the 5 root 2, what you can do is if you type in root 50 and 5 root 2 in the calculator, if those are the same value, then you simplified it correctly. So there is what your calculator screen should look like when you type them both in. And notice the decimals are both the same. If you're wondering where the square root button is, it's second and then x squared, because the little blue above the x squared, there's a radical, a square root. All right, last set of problems to solve. If we have parentheses, we can solve this by taking the square root of everything that is squared. The reason we can do that is because square roots undo squares. Now, when you take the square root, don't forget to write plus or minus. So we undo that and we get x plus 5 equals plus or minus 6, because that's the square root of 36. Now it's solving it just like a regular problem, but in order to do that, I'm actually going to write it as both equations, because you're going to see we're going to get two different numbers, and there's no shortcut way to write both of those numbers. So this equation means x plus 5 equals 6, or x plus 5 equals negative 6. So now we just have two little baby equations to solve. Let's subtract 5 from both sides, and we get x equals 1. And on the other baby equation, subtract 5 from both sides, and we get x equals negative 11. Those are our two solutions, x equals 1 or x equals negative 11. Try the next one on your own. All right, x minus 9 squared equals 64. Take the square root of both sides, and don't forget to plus or minus. So we get x minus 9 equals plus or minus 8. When we write the two equations, we get x minus 9 equals 8 and x minus 9 equals negative 8. Add 9 to both sides, we get x equals 17 or x equals 1. Those are our two solutions. For the last kind of problem here, we notice that the parentheses squared are not by themselves. We really need to get the parentheses squared by themselves on that side. So that pesky 3, we're going to divide 3 on both sides. That way we have just one thing squared. 3's divide out, and we get x minus 5 squared equals 6. Take the square root of both sides. Don't forget the plus and minus. Notice we don't have a perfect square, so in some ways this again makes it slightly easier. Let me show you why. Well, x minus 5 equals plus or minus the square root of 6. I'm going to just add 5 to both sides at this stage because we could write them as two separate equations, but we can't combine 5 and root 6, either adding or subtracting, because a square root can't combine like terms with something that's not a square root. So we get our final answer is 5 plus or minus the square root of 6. Notice that means two different equations, 5 plus root 6 and 5 minus root 6, but we can write it just like that. Try this last one on your own. Alright, did you get it? First, divide both sides by 4. You get x plus 10 squared equals 6. Take the square root of both sides. X plus 10 equals plus or minus root 6. Subtract 10 from both sides, and x is equal to negative 10 plus or minus the square root of 6. Thank you very much for watching.